Hello everyone, welcome to Reactify Labs. Today we will talk about another Leetcode problem called longest substring without repeating characters. This is also a very famous problem and has been asked in many interviews including the Google. Okay, so the problem statement says you are given a string, okay, and you have to find a substring, okay, a substring which should be longest, okay, and without repeating characters. It means if A has come once, it cannot come again. If B has come once, it cannot come again. Okay, and the constraints is that it can contain letters. English letters means A to Z, capital A to Z, digits, symbols, spaces, anything. Okay, anything it can contain, right? So now that we know the constraints, we know the problem statement, let's see the examples of how it works. So for example, if you see this abc the answer is abc. Why not abc? Actually the answer is 3. Okay, because abc is the longest substring without repeating characters. We don't have any substring which is longer than 3. Okay, so that's why we have to return 3, not the answer, because the answer can be, if you see, other than abc, the answer can be bca as well. Okay, the answer can be bca as well, or the answer can be cab as well. Okay, so bca, cab, these can also be the answers. So that's why we don't have to return the answer, we have to just return the length. Okay, so even though there are answers bca, cab, still the longest is 3, right? Because all are 3. Next, if you see b, we have 5 times b, so the answer is 1. In this case, if you see, the answer is 3 again. Why? Because of this, either WKE or KEW. Okay, both are 3. So the answer is 3. Okay, so this is the answer, not this. Okay, so this is what the problem statement is. This is the sample case also. So let's try to see the solution. Okay, let's see how we can do it. So first of all, in this problem, let me tell you one thing. As I said, it contains A to Z, 0 to 9, and other characters, okay, special characters. So in ASCII, there are only 256, right? So in ASCII, these only combine to be 256. So either we can use a map or we can use just an array of size 256. Both will do our work, right? Both can do our work. So both are fine. But yeah, in the interview, if the interviewer asks you what will be the time or space complexity for this one, you have to say, like, even if you use a map or an array, whatever you use, okay, you can tell them it's constant. Okay, it's order of 1, it's a constant, because even if you use a map, it will still not contain more than 256 keys. And if you are using an array, it's explicit here that it's 256. So you can tell them it's the order of 1. Okay, it's a constant time, a constant space complexity. Okay, and what will be the time? The time will be like the size of the string. That's it. Okay, so let's see how we should approach this time kind of question. So let's write down the input abc, bb. Okay, so we have to use a map to keep track of if something is already visited or not. Okay, um, like this, let's say if we start here, so we have a map. Okay, this map we mark it like, okay, we have visited A. Okay, then we move, okay, we have visited B. Okay, then we move again, okay, we have visited C again. We have visited C. Now when we come here, we see that, okay, we had already visited A. It means now till this point only we saw no duplicates, but here there is a duplicate, so we cannot move, and actually we have to process something here, right? So one thing you can ask me here is, what do we need to do? Like, is this a counter map or a visitor map, right? Do we need to just maintain a visitor count, or like boolean count, like just 0 or 1, like 1 is there, yes, true, Is it like this? No, actually we need a visitor count. Why? Let me explain. See, what we did was, when a came, okay, when a came, we did it like this. Okay, in the map a was there. Okay, a became 1. So now b came. In the map b became 1. Then c came. In the map c became 1. Okay, now when a came again, now you know that, okay, when a came again, you, till this point you didn't find any what do you say, repetition, any duplicate. So you can just find answer at every step. Okay, like for example, if you saw a, okay, there was no duplicates till this point, it means your answer was already 1. Okay, now you see, you went till b, you see, okay, still there are no duplicates, you can update your answer to 2. Like at least the maximum answer is 2 now. Now when you went to c, again you can just update it, like, okay, there was no duplicate, so yes, the maximum answer is 3, at least 3. Now we move forward. So if we move forward, we get a. So what we can do is, we will have another pointer here. Okay, we will have another pointer. What it will do is, it will see that, okay, it was here, it was at a, says that, okay, I can see a here. Okay, but if I can see a here, it means that a can be made 2, right? So we have to move this pointer until we see this as 1. Okay, so we have to move this pointer. So let's move this pointer. So if you move this pointer from here, if we just move this, so actually what happened was, this pointer was incrementing the count, this pointer is going to decrement the count. If we just move to this point, the counter of a got decreased to 1, right? So this is what it did. Now the counter is 1. Again, if we update our answer, it will still be 3, because it cannot be more. Next, when we moved this counter to this point, we got like b as 2. Okay, but again, if we move this counter from here to here, now b is again 1. Again our answer is updated to 3, right? Similarly, let's move this counter, this pointer here. Again, counter for c became 2, because we have 2 c's now. Now we move this pointer to this point, and again this is 1, and we have again our answer as 3, right? Now let's move to this point. If we move here, the counter of b is 2, right? And now we have to keep moving it till the point we see the counter of b as 1. So if we move this point, the counter of a becomes 0, because there is no a here. If you see, no a here, right? Now if we move this counter, this pointer, then we again get b as 1. And if we try to update it, the maximum is still 3, right? Because this will give us 2. And again, if we move it here, we see that, okay, again b became 2, so nothing, still our answer is 3. So that's why we need this. We need a what do you say, counter pointer, because if you just keep it like 0 or 1, like visited or non-visited, then what happens is, if let's say at this point, some like hypothetical scenario, if at this point you had one more b, okay, in that case, if you had just like moved, okay, I moved from here to here, then your b would have changed to 0, right? But it's not the case, the b is still there. So that's why you cannot use a boolean visited array. Okay, you cannot use this, you have to use a counter visited. Okay, so you have to keep the count of how many times you have encountered a character. So this is what you do, you iterate. Okay, basically iterate over the input. Okay, keep a counter, okay, and 2 pointers. That's it. So yeah, that's all there was in this video. Okay, this was the gist of it. What you have to do is, you have to just keep moving forward. You have to just keep moving forward. You have to keep increasing this pointer. You have to keep increasing this pointer, increasing until you found a duplicate. Okay, if there is no duplicate till this point, you can just calculate your answer. Again, if you move here, there is no duplicate, you can update your answer. If there is again you move and no duplicate, you can update your answer, right? You can keep updating your answer until you find a duplicate. And also there is one more thing. Maybe you can ask that why we are doing it like this. Let's say for the answer a b c b b. So our map is, if you see, like let's say the pointer is like this. this cannot be it, this, okay. So A is 1, C is 1, B is 2, right? So you can say that, okay, we have moved B here, okay. What if there was a C also? Like if C was also 2, then why are not we checking everything? Like why are we not checking everything in the map? Why? Because we don't need to check everything in the map, because as soon as we encounter a duplicate, we shift to this pointer, we start moving this pointer, because there is no point if there is already another character's duplicate, we cannot move to some other character, okay. So as soon as we find a duplicate, we move the counter. So let's say if there was a 2C, means some C would have been encountered here. So in that case, as soon as 2C's got encountered, what we would have done was, we would have started moving this pointer from here until we had cleared this C, okay, and we had reached this point. So that's why we are not considering like iterate over everything in the map to check what all values are more than 1. So that's why we are not doing it. We do not need to do it, because as soon as we find a duplicate, we start moving the left pointer until this duplicate is eliminated, okay. So let's take any random example and I'll end this video. A, B, X, Y, P, Q, A, Z, E, F, M, L, N, P, O, okay. So it goes like this. There is one pointer here, there is one pointer here, okay. So we see that for the map, this is our map, okay. So we get for A it's 1, okay. We move forward, we move to B. So for B it's 1, and our answer, the answer keeps updating. For A the answer was 1, now B came, the answer got updated to 2, okay. Now X came, so X is also 1, the answer got updated to 3. Y came, yes, Y is also not a duplicate, the answer got updated to 4. P came, it's again 1, the answer got updated to 5. Q came, Q is also 1, the answer got updated to 6, okay. Till this point it's fine. But again A came, but we can see that, okay, this makes A2. So we keep iterating from here, okay. So this will keep iterating. It came here, it sees, oh, okay, A is duplicate. So what we do is, we remove this, like we made this 1, we move this pointer forward, and we will try to see what's the length now. If you see the length between these two pointers, it's now 5, okay. So the answer will not be updated, because the answer should be the maximum value, because it says longest substring, okay. So the answer will not update. Now we move forward, okay. So we come to Z. So in this case, Z is now 1, so answer updates to 7. E is again 1, so answer updates to 8. F is again what? F is not present, 1, answer updates to 9. M is again 1, the answer updates to 10. L is again 1, so answer updates to 11. N is also not present, N is again 1, answer updates to 12. P, now P again came, so what will we do now? If you see, P is already there, so first of all we make this P as 2. Now we start moving this forward, okay. We start moving this pointer forward. From here, no, the P is still, so what will happen is, when P moves forward, so B becomes 0, okay. Then it comes here, okay, X becomes 0, then it comes here, Y becomes 0, yes. Now we encounter P, so this will decrement P, so P will become 1 and this will move forward, okay. So as soon as this happens, we know that, okay, now something will be updated, so this length will be something which will be less than 12, right? So we will not worry about it, and we will move this pointer now forward, okay. O came, so O was not present, so O is 1, and the answer is still less than 12, whatever it is, this length is whatever it is, it's less than 12, so the answer is not updated, the answer is 12. So this will be returned, okay. So yeah, I hope this gives you a good understanding of how to solve this problem and these kinds of problems. if you see you have to take care of repetitions or duplicates in something, this kind of like two pointer approach is good. Okay, two pointer sliding window, you can say this try, you can try this on other questions as well. So yeah, I hope you like the video. Thank you for watching. Please remember to like, share and subscribe. I will see you in the next one.